Welcome to the Health Edge, translating the science of self-care. I am Mark Pettis, and with my friend and colleague, John Bagnulo. John, good morning, my friend.
Good morning, Mark. It's great to see you.
Great to see you here in early June. The sun is high in the sky, and it's just a great time of year to be embracing longer days and more fresh produce, and the mood tends to shift, right, John? I
Yeah,
find,
yeah,
not just in my own personal life, but uh, I'll go to a lot of our local sporting events, and parents are in a good mood, the kids are in a good mood, and there's just something shifts this
yeah,
year,
yeah. Yeah,
and
I think we wait from, I guess, around early November, maybe even late October until now for for these long days. And like you said, everything's green. You have so many choices now, and you go to the local farm stand. Yeah, it's a beautiful time of year.
it is a beautiful time of year, and one that we do not take for granted. We have a really interesting topic to uh, reflect on in this episode, John, around bile quality, bile acids, and the extraordinary and not frequently discussed interaction between the bile that we produce in the liver, stored in our gallbladders, and then excreted uh, with meals that we consume, and the interaction that these bile salts have in relationship to our gut biome, all these fascinating metabolic byproducts and biochemical interactions, and the downstream effects of all of that on human health, from appetite management to
Mm.
cardiovascular health to systemic inflammation to gut health. And so, I love, John, that you brought this up in your recent Substack, because it really opened my eyes to a part of our sort of biology that people just kind of take for granted. And your people, I think, are aware of gallstones and that kind of thing. And a lot of the clinical community bile is all about gallstones. You either have them or you don't.
Yeah.
Uh, so this takes it into a much more interesting and nuanced context.
Yeah, it's really incredible. I mentioned a little bit of the background to hear my digging into bile. It's I think a lot of our listeners appreciate its role in detoxification, and that's what I initially set out to really write about was, what does the average American's bile contain? Because I'd heard of a study that was going on where they were attempting to measure different levels of toxins that we know bile is the primary pathway out of the body. And for our listeners that don't understand this, I'll just back up for a moment and say that heavy metals and any toxins that have really large molecular weights and are more fat soluble, more difficult for the body to get into a water soluble state. So all of those toxins leave via the bile. And, that's the liver's primary outlet for these toxins. And then when that bile carrying those toxins, when it gets into our large intestine, if it's not bound to some sort of soluble fiber, and different fibers have different affinities for bile, but if the bile is not bound to a soluble fiber type, then it ultimately gets recycled, or it gets absorbed intact, and it goes back to the liver. So the bile and the toxins that the bile contains can essentially be recycled if we don't have something to break that cycle. And that's called, enterohepatic circulation, right? Just things are just going back to the liver. And we want to break that with having the right types of fiber in the gut, and also having the right types of gut bacteria that can help metabolize some of those bile acids into things that are less inflammatory, more anti-inflammatory. So that's initially what I was attempting to write about. But when I really dug into it, Mark, it was incredible for me to realize, like, wow, just how much regulatory activity bile has for the body as a whole, outside of the whole detoxification role that it plays. And to your point, most of us just really think about, bile as something that we need to emulsify fat, right? We know that it does have, an influence on, like you said, appetite and things like that. But I had no idea how much it was intricately involved with a person's overall metabolism. I thought for me, that was, I think that was really eye-opening, that bile has a huge stimulatory effect on brown adipose tissue or brown fat, which we know is really metabolically active. And it can become a big part of a person's overall daily energy expenditure or metabolism. So there are all these different things that, I just really underappreciated the role that bile has in, regulating the microbiome. It has some really strong kind of inhibitory effects on pathogenic species of bacteria, which, again, we need all the help we can in terms of regulating some of those more opportunistic bacteria that can cause more inflammation and can cause issues with that ecosystem. So it's just a really incredible molecule. But like you and I always talk, when I look at the role that bile plays in all of these different areas of our physiology, what becomes really clear is that the more Paleolithic, more ancestral lifestyle and the more ancestral foods that we would have eaten for thousands of years, those foods are much more supportive of having larger quantities of bile and having bile with the appropriate viscosity, by and large, a thinner bile, which we can get into in a moment. So again, that ancestral lens, it seems like without fail, it always, illuminates the lifestyle that really is conducive for us to have the type of bile and the quantities of bile that are ideal for all of that areas of our health.
Great context to dive into this, John. And we'll look at a few papers, recent papers, reviewing. These are reviews of current understanding of the interaction of bile acids, these metabolites, with the biome and with various aspects of cardiometabolic health. And then we'll conclude with foods that are associated with some of these attributes of bile that you touched on, John. And I love that paleo anthropologic lens, because it's clear that I just reflect back on my medical journey and all, it as a resident back in the early 1980s, the number of people coming into the hospital with gallbladder disease, their gallbladders would ultimately be removed. Many would then have malabsorption issues because they weren't breaking down fat as much. And it was kind of as a resident, and then ultimately as my career evolved, I went on to think of it as kind of a nuisance, who needs a gallbladder? These gallstones are, everyone seems to be getting them. And it was, never really crossed my mind that this was a phenomenon of contemporary life, like most modern chronic complex health issues. And you saw so much of it that you just began to take it for granted. People get gallstones, you tell them to, back then with the low fat seemed, well aligned with reducing gallstone formation. None of that ever really proven. But we're reminded that things in our food supply today and things in our environment that alter the gut ecosystem. I mean, it's pretty much of a multifaceted assault on all these drivers ultimately of what appears to be much more than just the likelihood of forming a gallstone or not. And so I really appreciate that context. So I'll pull up some
Yeah.
slides, John. And
Yeah. And just while you're bringing those up, it's interesting, you refer to the early 1980s, and that's, as you know, Mark, that's when kind of the low fat, higher carbohydrate dietary recommendations really started to take off, right? And that's when actually some of the best, or I'd consider landmark papers on bile, gallstone formation, or bile viscosity, which again, if it becomes more viscous and thicker, tends to lend itself to greater gallstone formation. But some of that research in those early 1980s was in response to the significant rise in gallstone formations, and in the, obviously the removal, the surgeries that really started to explode. Well, it's no mystery that those occurred. That whole, in epidemiology, that rise in gallstone issues all occurred in close proximity to those, that new kind of low fat, high carbohydrate diet approach. So there's actually a paper, and it was a 1983 investigation that looked at the role of refined carbohydrates in gallstone formation. And, the authors conclude that the mucin content of gallstones from an individual on a high carbohydrate diet is considerably greater, and that mucin was one of the primary constituents to those gallstones that was very different from an individual with a lower carbohydrate and less refined carbohydrate in their diet. And, again, that's a landmark paper, and occurring in 1983 in response to, what you just shared with us in terms of your observations. So, yeah, it all goes back to how much discord is there between the lifestyle, the diet that, our ancestors had, 15, 20,000 years ago, and how radically things have changed. Well, there's usually a consequence to that. And we're seeing that with bile as well, which we can dig into now. But yeah, sorry to interrupt.
Fantastic, John. Love that. And that epidemiology really makes so much more sense in the context of what we're talking about here. And still I do not hear much discussion of this in mainstream medical, clinical thinking. This was a relatively recent paper that I found, John. I tend to, as you, look for systematic reviews, subject reviews, because it is harder to find interventional trials under this sort of topic. Again, unless you're talking specifically about gallstones, which is, right, that's where the money is. So if there's any research, is how can you manage a gallstone without taking the gallbladder out? Right. That's what it ultimately gets reduced to. But this is a nice recent paper, and just a few graphics from this paper, which I'll just touch on briefly, John, and then I'll let you run with this, because this biochemistry is so fascinating, and again, it just helps to remind our listeners that cholesterol, which is one of the perhaps most important molecules in human biology, is again the backbone for bile production. And cholesterol, essentially, in the cytochrome enzymes, of which there are many in the liver, to the point that you made earlier, John, that help us modify molecules for elimination. And so you see this cholesterol is being managed by these many liver enzymes, ultimately producing these primary bile acids, cholic acid and chenodeoxycholic acid, right? Great Scrabble words. This is what the bile releases, what the liver releases into the gallbladder, which is really a kind of a storage structure for bile that can then be contracted and released in temporal proximity to the consumption of the food that we're eating to help break that down. And then we see that these primary bile acids are really, in terms of all of the interesting metabolic effects and detoxification effects, this is the substrate that ultimately in the gut is modified through these hydrolases. This is a very common oxidation chemical reaction that adds what we call a hydroxyl group, right? This oxygen hydrogen group. You can also see dehydroxylases where a hydroxyl group might be removed. And the addition and the deletion of a hydroxyl group can totally change the function of that bile acid metabolite, and but ultimately you get these secondary bile acids, which are listed here: the deoxycholic, the lithocholic, and the ursodeoxycholic acid. This is where you start to see active functional effects of these ultimately these mediators of cardiometabolic health and gut health. And so it's a beautiful, complex production and modification system. And then to reemphasize an important point that you made, John, 95% of what is produced can get reabsorbed in this enterohepatic, and it basically goes through this recycling process. And so if you're carrying toxins and you want to be eliminating more, you need to be thinking about what you can do to enhance recycling of bile salts that aren't accompanied with toxins, and then elimination of those that are. And so, yeah, that's just a brief overview. John, do you want to add anything to that?
Yeah, I mean, this is an awesome slide, Mark. Thanks so much for digging this one up and including it, because I think it really it shows the different fates here of bile. And the one that I guess I could speak to the most of is out of those secondary bile acids is lithocholic acid, that also abbreviated LCA in papers that talk about bile metabolism. That one is anti-inflammatory. It has anti-proliferative effects on potential colon cancer sites. It's a really interesting molecule, but of course you need the right gut bacteria to catalyze the formation of that. And what research has shown is that diets higher in vegetable fiber, not fiber from grains or even from fruit for that matter, but vegetable fiber, which, again, it can be made up of both insoluble and soluble fiber. And I think a lot of researchers feel that it's the soluble fiber that's most responsible for establishing the right gut bacteria for optimal metabolism of bile. But that LCA is what you want to have more of when you're talking about bile acid metabolism, because if bile acids are not altered in any way, they can be, very inflammatory to the cells in the lining of the large intestine, and can be a huge risk factor for colon cancer. Those unbound bile acids are really, really a problem. So it's about having the right gut bacteria, and again, to build it, the ecosystem that you need to have those right gut bacteria, it's having more soluble fiber, and getting that from more vegetables and less from bran and things like that. Now, in terms of, if you just go back to that slide for 1 second, because I liked how it showed 95% of that bile going back to the liver. To get that number from what you see there in terms of what's lost, here it's around 5%. To get that 5% up to 10 or 15%, it really requires the inclusion of some specific types of soluble fiber. One of those is, again, there's another really great Scrabble word. I like that, how you coined that. Beta-glucan. So that's beta hyphen capital D hyphen and then glucan is the type of soluble fiber that has the greatest affinity or ability to bind onto bile acids and to carry those out of the body so that they don't get recycled. Now, beta-D-glucan is found in a few different foods, some of which I think are better for overall health than others. So like oats, for instance, oats are incredibly high in beta-D-glucan, but again, oats are a very carbohydrate-dense food. They're not really that nutrient dense. And I think for someone with insulin resistance or someone that wants to lose weight, I don't think oats are a great choice. But you also have beets and carrots as being great sources of beta-D-glucan. And I think those have really a lot more going for them and are much more conducive to overall health. So, again, that's one of the best qualities of oats would be the soluble fiber, the beta-D-glucan. But I think you can get really similar levels from eating beets, and you can get other benefits from those as well, much higher potassium levels. And so now you've got different choices when it comes to some of these types of fiber. And then the next type of soluble fiber that is not quite as good as beta-D-glucan, but is still very good is pectin. Pectin is found in, it's found in things like, obviously, the peels of citrus fruits, like, lemons and limes. If you use a lemon peel, for instance, in making a smoothie, you can get really a robust amount of pectin. Some people take pectin as a powder. They mix it with water and they drink it, and that's fine as well. Again, it just depends on, how much people want to add to the things they're drinking. But pectin is phenomenal as well at disrupting this enterohepatic circulation. Yeah, thanks. I just wanted to just mention that.
Great stuff, John. Great stuff. And we'll come back to foods that one look at in a more discerning way. But sure. I love the nuance, John, that you bring to the distinction between beta-D-glucan from, let's say, an oat source versus a root vegetable like beets or carrots. Same molecule. And I could imagine, John, some might be a little surprised to hear some consternation of oats.
Yeah, I'm sure.
Which is probably one of the more frequent cultural memes as a health food. And so we make the distinction often, given the high prevalence of insulin resistance. Conservatively, 70% of the American population, and oats as an example, they're redeeming values clearly, but as a carbohydrate dense food that is acellular, we often talk about how the carbohydrates in oats are not contained within a cell wall. They're more easily accessible. They break down and rise very quickly. And anyone who has a continuous glucose monitor will find their data pre-post a bowl of steel-cut oats. I've done that many times, and I'm just stunned at how high my sugar will rise, as opposed to the beta-D-glucan that you'll find in, say, a root vegetable, which is within the membrane, the cell membrane of that plant, and it takes a little more work to break it down, and the excursions of sugar and ultimately insulin aren't as great. So there's a really nuanced example. I just want to emphasize that really awesome point that you made, John. And now let's look at just another graphic here of the many ways. This is just a kind of an overview, and I'll let you run with this, John, of how these secondary bile acids have multiple metabolic effects. And John, I'll let you run.
Well, look, I mean, I think the best thing we can say about this, and I'm sure the GLP-1 molecule here really stands out, right? Because there's just so much interest and momentum with that particular, GLP-1 type drugs. I would say the greatest thing about this is that everybody knows that a high-fat meal has like greater satiety value, right? If we eat a couple high fat meals a day, we're not looking for food for the rest of the day. That would be like my real high level summary here, is that when we eat a higher fat meal and we get a greater release of bile acids, those bile acids are communicating with our metabolism, with our appetite, with the body's tendency to expend energy from different stored sources. And again, we could back up, we could look at the Paleolithic kind of human experience and say, well, our ancestors ate, a much, much higher fat diet. And because of that, bile was released in much larger quantities, and it had all of these very favorable effects on our ancestors' physiology and our ancestors' ability to really thrive when there were going to be greater windows of time between meals. So that's something I always want to emphasize, is that bile, which again, you've already mentioned this, but for our listeners' sake to hear it twice, we tend to release greater amounts of bile with higher fat meals. And, the bile is, yes, it's emulsifying that dietary fat. It's allowing us to digest it properly. It's creating a greater interface between our digestive juices and in the fat in our diet, which can tend to separate, right, from those. So it's accomplishing that. But what we tend to, and I have always failed to fully appreciate, is that the bile is also governing where the body is going to generate energy from. And if the body is experiencing this surge in bile acids, the bile acids communicate with the body to basically burn fat. So it's really turning up the body's thermostat in a way. It's saying, you know what? There was a high fat meal just consumed. Now let's burn. Let's burn fat. Let's raise our energy expenditure. Let's get things done. Again, this is just, real high level stuff, but you can see that you have appetite suppression. You have a higher level of insulin sensitivity that's going to be generated from this. You're not going to be producing the same types of lipids. Bile acids have also been shown to really influence the type of LDL molecule we produce, for instance. So I think that would be my high level summary of this, Mark.
And that's just an amazing example of how, again, bile acids as a byproduct of sort of day-to-day metabolism, right? They sit in these receptors in the liver, in the gut, in the pancreas, muscle, and exert this network of metabolic effects. So you really see how these pathways interact in such integrated and coordinated ways. And of course, all of this is happening, right? You've got literally billions of biochemical reactions, all in some way synchronized and choreographed to optimize metabolic function, and that was the mandate for human survival. And this is just a really elegant graphic in terms of the many ways that a seemingly trivial bile salt exerts many profound metabolic effects. And in the same way, you've touched so nicely, John, on the things that we frequently emphasize, the importance of fiber quality, diversification of the gut biome. And we're reminded that in modern life, the foods that we eat, the antibiotics, residues that are in so many food products, the extent to which the standard American diet is so deplete of quality fiber. In this graphic from the review article that we showed earlier, you can see how dysbiosis, which has so many modern American drivers. We've talked about the research of the Sonnenbergs at Stanford. And they've got some great reviews of sort of the epidemiology of why it is that the modern American gut biome ecosystem looks so different than it probably once did, and certainly very different from ancestral research that has looked at cultures like the Hadza and Jeff Leach's work. But you can see how dysbiosis interferes with this conversion of the primary to secondary bile acids, how antibiotics, whether we're taking them for an infection that may not otherwise require an antibiotic, or we're getting them from the foods that we eat. We know glyphosate, for example, has antimicrobial activity. So we're in these modern environments that are well suited to assault this system. And so here again, you see reduced secondary bile acid synthesis because of changes in the biome, and then the extent to which a lack of quality soluble fiber will also interfere with these bile acid pathways, right? So you begin to see how we're lacking many of the things that we need to drive the system more optimally, and we're getting overexposed to things that we probably need to be managing a bit more thoughtfully, also disrupting the ways in which these systems support our health. Anything else on this graphic, John?
No, just the last component there, physical activity, lowering bile acid concentrations by really moving things along, by speeding up peristalsis, those wave-like contractions. So it's amazing how physical activity sort of clears the playing field of, right?
Yes.
Bile acids, yeah.
Great. And then we can, just as we conclude this, John, in a recent Substack
this is
you've got a nice list of foods that can support this process in a more optimal way, and foods that can disrupt it. And so maybe we can just go through these quickly, and then we'll bring it home.
Yeah, all of these foods listed here contain specific fatty acids that have been shown to promote a thinner, less viscous bile, one that will have a greater ability to be released or purged, I guess, from the gallbladder when necessary. So again, thinner bile. When the gallbladder contracts, you're going to get a greater amount of that bile released. It's going to typically be more effective. It's not going to form that thicker sludge and have increase the risk for forming gallstones. But again, downstream, so to speak, once it's released from the gallbladder, thinner bile is also much more effective at communicating with all the different facets of our physiology that we've talked about. So, black seed oil, very, very high on the list here because of some of the unique fatty acids that it contains that you really have a hard time getting anywhere else. Freshly ground flax seeds or flaxseed oil, extra virgin olive oil. Again, that's high in squalene, and squalene is a really interesting molecule. It's also found it's found in shark cartilage. It's only found in a handful of foods on the planet, but it does end up in bile. And it does have a very profound effect on the bile's consistency and being very protective against that bile thickening. So that's why, extra virgin olive oil, again, not that it needs more evidence or support. It's often looked at as, the healthiest fat that a person can consume. And I think that it's great when things are actually true, because there's so much of that misinformation out there. But in the case of olive oil, it really sticks in just about every application. So then again, oily fish, small oily fish, excellent for bile consistency and having healthier bile. Avocados, almonds, pecans, and you'll see that most of these have high monounsaturated fat contents. That's, I think, something that you could safely draw a conclusion around here, is that monounsaturated fat tends to have, just like it does for most areas of our overall health, it really lends itself to having better bile qualities. And then you get down into the coconut oil and the pasture raised butter, and again, some of the unique shorter chain saturated fatty acids that those contain. So those are your best fats and oils for having that. What you don't see on here, obviously, is you don't see highly polyunsaturated seed oils. You don't see some of the altered fats, which I like to refer to as fats that have been brought to really high temperatures. Those are the worst fats. And what I found, and you may have heard this too over the years, Mark, is that for many individuals, and I don't have I have no clinical study to support what I'm about to share, but it's just been 25 years of counseling people and hearing about the last meal or the last few meals that precipitated a gallstone attack. And time again, it was a meal that was comprised largely of some type of fried food, whether that be French fries, whether it be fried chicken or fried clams, whatever it was. People have repeatedly shared with me that was the last meal before they had to go to the emergency room. And it's really it's easy to understand that, because when a oil is brought to really high temperatures, its molecular structure starts to change in a way that it becomes very stiff, very rigid, much more difficult to digest. But also, when those fatty acids ultimately do get absorbed into circulation, their role in the subsequent bile formation that would include them really alters the thickness of that bile. So bile will really thicken, and gallstone formation will really accelerate when you have these kind of altered oils in the diet that ultimately start to contribute to the composition of what's in the gallbladder. So that's why you see the worst foods are those which are foods fried at high temperatures, and in the case of donuts, also contain a very high refined carbohydrate content. That's where you get, that's a double whammy. When you have a food that's high in sugar, high in refined carbohydrates, and it's fried, or you have a meal where someone's drinking, let's say someone's having a soft drink or soda, and they're having some type of fried, whether it's fried chicken or something, then you're asking a lot of the body in general, but you're asking a lot of the gallbladder, and you're really creating issues with bile, the way bile is formed in the gallbladder when those types of meals become frequent over a day or two. So those are the worst foods: refined carbohydrates, foods which are made up of oils that have been brought to really high temperatures. Hydrogenated oils, luckily, have started to really, they've started to disappear at least from the average American's diet, because they're just, states like California and New York, had legislature put in place that prevented food manufacturers from selling those in those states, and that really helped a lot. So hydrogenated oils aren't on the list per se because they're not as common now as they were 15 to 20 years ago, but that would also be an example of an altered oil.
Great. Thank you for that, John.
Yeah,
sure. That we had an acronym or a mnemonic when people presented with, usually it was abdominal pain, nausea, maybe vomiting. And of course, their pain could usually be localized to the right upper part of their abdomen where their gallbladders were. And the mnemonic, it was the F's, female, fat, and fried foods.
Yeah.
And almost always that was the context whereby they would present. And so I love that list. And of course, these are the foods that are just so highly palatable and that, right, people love. And we'll end, John, with this last list of really positive food considerations that really touched,
Yeah.
I think, this important issue of soluble fiber, and I'll let you go through this list, John, and then we'll.
Yeah. Yeah. So the groups of vegetables or greens, I should say, that have the most really positive effect on bile production, bile qualities, and have very great protective effects against gallstone formation are members of the chicory family and then greens in the brassica family. Now, the common denominator across all of those greens, which again make up the top 5 on this list, and then also make up, 2 or 3 of the bottom, is that they're collectively they're referred to as the bitters. The root of that word, from European, I guess, heritage, you'd say, where bitters were used for different medicinal purposes. But one thing, whether it's in, Chinese medicine, wherever you look in the globe, is that bitters have very profound effect on gallbladder contraction, bile production, bile secretion. And so that's why you see, like, for instance, dandelion greens are a member of the chicory family. So are radicchio, endive. These are really bitter greens. I would put coffee in there as well, even though, obviously coffee is a beverage, but one of the most positive attributes about coffee is the bitterness and the bitter content that we know. And I'm pretty sure, Mark, that you and I have already talked about the associations with coffee consumption and gallbladder disease. Gallbladder disease, it appears to be very protective, from what I've looked at. I think we talked about that, maybe it was a year ago or so. Yeah, but so your brassicas, your members of the chicory family, which are dandelion greens, radicchio, endive. There are a few others, but those are all very, very potent gallbladder contraction, bile secretion stimulants, which is good to have on a somewhat regular basis. And then your brassicas, which are going to be arugula, mustard greens, collard greens, kale to a much lesser extent, because it's not as bitter as, let's say, mustard greens. But these are, those are, again, the bitters. And then you have beets, you'd see here again, and that has more to do with the ability of beets to bind on to bile acids, carry them out of the body. And one thing I failed to mention, which is important here, is that when bile acids are repeatedly recycled, when you don't break, or when an individual doesn't break that enterohepatic circulation, recycled bile, when it starts to appear the second and third time, that in itself starts to lend itself to a thicker bile, and a greater risk for forming gallstones and having kind of that sludge-like consistency that we don't want. So, that's why beets are on that top 10, is that it's the most effective food for really eliminating those bile acids and not letting them get recycled.
Well, that's a great place to adjourn on, John. It hopefully our Health Edge listeners appreciate a very different and nuanced context of what's happening in their bile production, in gallbladder function, and ultimately so many aspects of metabolic health and detoxification, and some great suggestions for how one can incorporate paleo ancestral principles, not just the nutrition and the movement, which you touched on, the peristalsis. It all has a remarkable place. So fun discussion, John. Thank you for the topic.
Yeah, thank you. I really appreciate the opportunity that you and I have to talk about these things. I look forward to it every week, Mark. It's great.
Well, yes, as do I. And we just want to thank our listeners for tuning into the Health Edge. If this is content that you find has value for you, or maybe someone you love and care about, please share with them. John and I have an absolutely pathetic social media presence. And we're happier because of it,
Right.
but it doesn't always allow content to reach as many people. So be it. So we appreciate our loyal Health Edge family, and we'll continue to scour research that is really changing, I think, the way we think about self-care and lifestyle functional medicine. And Josh, just always a pleasure and great to see you, and have an awesome week. We'll see you next week.
Same here, my friend. Take care, buddy.
Take care.